According to the National Electrical Code, a mast is defined as that part of an antenna support structure that is above the ground level and below the radiating structure. It's important to note that any metallic object extending more than 6 feet above ground is considered an antenna support structure. Grounding of a mast is required by National Electrical Code Section 810.15b2 for all antenna structures exceeding 18 feet in height above ground level, regardless of their location in the building. The grounding of a mast or antenna support structure is critical due to the likelihood of lightning strikes. When lightning strikes an antenna structure, the electrical current must have a path to ground to dissipate. If there is no proper grounding path, the current will find an alternate path, which may be through the coax cable or even a person touching the antenna. This could result in injury or damage to the equipment. Bonding of the mast and coax to the grounding system is required to minimize potential differences between the two systems. These potential differences could cause arcing or sparking, which could then ignite nearby combustible materials. The coax cable shield should be bonded to the mast with an approved grounding clamp. The grounding conductor should be bonded to the mast within 12 inches of the coax bonding point. When installing satellite dishes on apartments, the installer must follow the requirements of the National Electrical Code as much as possible. If it is not possible to fully meet the requirements of the National Electrical Code, the installer must document any deviation from the NEC and obtain the approval of the authority having jurisdiction, known as the HJ. The authority having jurisdiction may require the installer to install a grounding rod or implement other grounding means that meet the requirements of the NEC. If you are interested in proposing a code change, you can do so by submitting a proposal to the National Fire Protection Association (NFPA). It is also recommended to contact the Satellite Broadcasting and Communications Association (SBCA) to see if they have any resources or information on this topic. Let's delve deeper into the specifics of grounding and bonding related to satellite dish masts, referencing relevant sections of the National Electrical Code (NEC), and clarifying common points of confusion. The NEC intent is to provide a safe installation that minimizes the risk of fire and electrical hazards. Grounding and bonding are key components of achieving this safety, especially when dealing with outdoor structures that are susceptible to lightning strikes. The primary reason for grounding a satellite dish mast is to provide a low impedance path for lightning current to flow to ground. This path minimizes the voltage buildup on the mast, which could otherwise lead to a flashover to other nearby grounded objects, potentially causing a fire or shock hazard. Section 810 of the NEC covers radio and television equipment. Specifically, Section 810.15 addresses grounding. It requires that antenna masts be grounded in accordance with 810.15 F through K. The size of the grounding conductor is specified in 810.15e. It refers to Table 810.16, which dictates the size of the grounding conductor based on the size of the antenna leading conductor. However, for masts, a common practice is to use a minimum of number 10 American wire gauge copper or number 8 American wire gauge aluminum grounding conductor. This provides a robust path for fault current. The grounding electrode system, as defined in Article 250 of the NEC, is what the grounding conductor from the mast should connect to. This system typically includes the building's grounding electrode, such as a ground rod, ground ring, or connection to the metal water pipe. The goal is to create a common ground potential throughout the electrical system. Bonding is equally important as grounding. Bonding involves connecting metallic parts together to create an electrically conductive path. This ensures that all bonded parts are at the same electrical potential. In the context of a satellite dish, bonding the coax shield to the mast is critical. This is typically achieved using a listed grounding block or clamp. The NEC requires this bonding to minimize voltage differences between the coax shield and the mast. If a lightning strike occurs, the current will be distributed, reducing the risk of a flashover. Addressing the concern about the resistance of the coax shield versus the grounding conductor, it is important to understand that the primary purpose of the grounding conductor is to provide a low impedance path for high-frequency lightning current. While the coax shield does offer some grounding capability, it is not designed to handle the magnitude of current associated with a lightning strike. Therefore, a dedicated grounding conductor is essential. When encountering pre-wired homes with the satellite cables are routed to a point on the roof or eave without a ground wire, it is crucial to prioritize safety and compliance with the NEC. If it is not feasible to install a grounding conductor that meets the code requirements, it is important to document the situation and discuss it with the authority having jurisdiction, the OJ. The AHJ may offer alternative solutions or grant a variance based on the specific circumstances. The 20-foot rule mentioned refers to Section 820.100, which addresses the grounding of coaxial cable shields. While there isn't a strict 20-foot limit on the length of the grounding conductor, it is important to keep the conductor as short as possible to minimize impedance. Using a larger American wire gauge wire, such as number 6 American wire gauge copper, can help reduce impedance in longer runs, but it is still best practice to keep the grounding conductor as short and direct as possible. In apartment buildings, grounding satellite dishes can be challenging due to the building's construction and the difficulty of accessing the grounding electrode system. In these situations, it is essential to work with the building owner or manager and the authority having jurisdiction to determine the best course of action. Options may include bonding the dish to the building's existing grounding system or installing a dedicated grounding electrode. It is important to remember that as an installer, you are responsible for ensuring that the installation is safe and compliant with the NEC. If you encounter situations where you are unsure how to proceed, it is always best to consult with a qualified electrical inspector or engineer. The National Electrical Code is updated every 3 years, so it is important to stay up to date on the latest requirements. The NFPA offers various resources, including training courses and publications to help you understand and apply the NEC. Furthermore, consider the specific challenges posed by different types of satellite installations and how the NEC addresses these scenarios. Firstly, consider roof-mounted satellite dishes. These installations are particularly vulnerable to lightning strikes due to their exposed location. In addition to grounding the mast, it's crucial to ensure that the coax cable is properly grounded at the point where it enters the building. This is typically accomplished using a grounding block that is connected to the building's grounding electrode system. Secondly, consider wall-mounted satellite dishes. Even though these dishes are typically lower to the ground than roof-mounted dishes, they still require proper grounding. The grounding conductor should be connected to the nearest accessible point on the building's grounding electrode system. Thirdly, consider multi-dwelling unit (MDU) installations. These installations often involve multiple satellite dishes serving multiple tenants. In these cases, it's essential to coordinate with the building owner or manager to ensure that the grounding system is adequate to handle the increased load. A common approach is to use a busbar to provide a central grounding point for all of the dishes. Fourthly, consider temporary installations. While temporary installations are not intended to be permanent, they still require some level of grounding to protect against electrical hazards. At a minimum, the mast should be bonded to a nearby grounded object, such as a metal fence or railing. However, it's important to note that this is not a substitute for a proper grounding system. Fifthly, consider the use of surge protective devices, SPDs. Surge protective devices can help protect sensitive electronic equipment from voltage surges caused by lightning strikes or other electrical disturbances. SPD should be installed on a coax cable and the power supply line to the satellite dish. Let's discuss the selection of appropriate grounding and bonding materials. The materials used for grounding and bonding must be compatible with the other metals in the system to prevent corrosion. Copper is the most common material used for grounding conductors, but aluminum can also be used in certain situations. When connecting to similar metals, such as copper and aluminum, it's important to use a listed connector that is specifically designed for that purpose. Grounding clamps and connectors must be listed for the specific application. This ensures that they are properly sized and constructed to handle the expected current flow. The grounding conductor should be protected from physical damage. This can be accomplished by running the conductor through conduit or by using a cable that is designed for direct burial. The grounding electrode system should be inspected regularly to ensure that it is in good condition. The connection should be tight and free from corrosion. If any damage is found, it should be repaired immediately. The authority having jurisdiction, OJ, plays a crucial role in enforcing the NEC. The AHJ is responsible for reviewing plans, inspecting installations, and issuing permits. It's important to work with the AHJ to ensure that your satellite dish installations comply with the NEC. If you have any questions about the NEC, don't hesitate to contact the AHJ for clarification. The NEC is a complex document, and it's important to understand the requirements before starting any installation. Here are some additional considerations for ensuring a safe and compliant satellite dish installation. Firstly, perform a thorough site assessment. Before starting any installation, it's important to assess the site to identify any potential hazards, such as overhead power lines or underground utilities. Secondly, plan the grounding system carefully. The grounding system should be designed to provide a low impedance path for fault current to flow to ground. The grounding conductor should be as short and direct as possible. Thirdly, use listed equipment and materials. All equipment and materials used in the installation should be listed by a recognized testing laboratory such as Underwriters Laboratories, AL. Fourthly, follow the manufacturer's instructions. The manufacturer's instructions provide detailed information on how to install and operate the equipment safely. Fifthly, inspect the installation after completion. After the installation is complete, it's important to inspect it to ensure that it is properly grounded and bonded. Sixthly, document the installation. Keep a record of the installation, including the location of the grounding electrode system and the size and type of grounding conductors used. This information will be helpful for future maintenance and repairs. Seventhly, provide training to users. If the satellite dish is being used by someone else, provide them with training on how to operate it safely. Emphasize the importance of not touching the dish during a lightning storm. Eighthly, stay up to date on the NEC. The NEC is updated every 3 years, so it's important to stay up to date on the latest requirements. Ninthly, consult with a qualified professional. If you are unsure about any aspect of the installation, consult with a qualified electrical inspector or engineer. Tenthly, prioritize safety. Safety should always be the top priority when installing a satellite dish. By following these guidelines, you can help ensure that the installation is safe and compliant with the National Electrical Code. Always remember that grounding and bonding are not just about meeting code requirements, they are about protecting people and property from electrical hazards. Take the time to do the job right, and you can have peace of mind knowing that your satellite dish installation is safe and reliable. Finally, let's consider the practical aspects of dealing with older installations or situations where the existing grounding is inadequate. In these cases, it is essential to assess the existing grounding system and determine what upgrades or modifications are necessary to bring it up to code. This may involve installing a new grounding electrode, upgrading the grounding conductors, or adding additional bonding connections. When working on older installations, it is important to be aware of the potential for corrosion or other damage to the grounding system. Carefully inspect all connections and conductors for signs of wear and tear, and replace any damaged components. In situations where it is not possible to fully comply with the NEC due to physical limitations or other constraints, it is important to document the situation and consult with the authority having jurisdiction to determine the best course of action. The authority having jurisdiction may be willing to grant a variance or allow alternative methods of compliance, provided that the safety of the installation is not compromised. Remember, the goal is to provide the best possible grounding system within the constraints of the existing conditions. Safety should always be the top priority, and no compromises should be made that could jeopardize the safety of people or property. By following these guidelines and staying informed about the latest requirements of the National Electrical Code, you can ensure that your satellite dish installations are safe, reliable, and compliant.